Hello, learners. Let me start with a simple but fascinating question. What powers your phone, moves your bicycle, or lets you lift a heavy object? The answer lies in one magical word: energy. In physics, energy is defined as the capacity to do work. That means if a body can perform work, it has energy. Now here's something cool. Energy is a scalar quantity. That means it has only magnitude, just a number, but no direction. The amount of energy a body has is measured by the total amount of work it can do. So if an object can perform more work, it clearly possesses more energy. From the muscles in our body to the fuel in a rocket, everything that performs work has energy in some form. Let's dive deeper into how energy and work are connected. This is where physics really starts to feel alive. Whenever a body does work, it uses up energy. For example, when you kick a football, your body loses some energy, and that energy gets transferred to the ball. Conversely, when work is done on a body, like when someone pushes you on a swing, the energy of that body increases. So in every case, whether energy is gained or lost, work equals energy transferred. That's a golden rule in physics. This is why we say energy is the stored form of work, and work is the active use of energy. All right, let's bring this to life with some real examples. Imagine a ball rolling across the floor. Over time, it slows down and stops. Why? Because it has transferred its energy to the ground through heat and sound. Now picture an archer pulling back a bow. That stretched bow stores potential energy. The moment it's released, that energy converts into kinetic energy in the moving arrow. Even burning fuel in your car engine is a transformation, from chemical energy to kinetic energy that moves the wheels. So remember, whenever energy changes form or moves from one body to another, work is being done. That's what physics is all about: energy and motion. Let's now explore the different types of energy you'll come across. And yes, they're all around you. First, mechanical energy, which includes two parts: kinetic energy, that is energy of motion, and potential energy, which is stored due to position. Next, heat energy, the result of particle motion inside matter, like when you rub your hands together and they get warm. Then, light energy, which comes from sources like the sun, light bulbs, or lasers. We also have chemical energy, stored in fuels, batteries, and even the food we eat. And lastly, electrical energy, the type that powers your gadgets and home appliances. So from the sun in the sky to the circuits in your phone, energy exists in many fascinating forms. Now here's something interesting. Energy doesn't care about direction. Unlike vectors like force or velocity, energy is a scalar quantity. All that matters is how much energy is there, not which way it's pointing. Let me explain. Whether a battery powers a motor clockwise or anti-clockwise, the energy output is the same. You can add or subtract energy amounts, like simple numbers. No need to worry about angles or directions. So the next time someone asks why energy is a scalar, tell them, because it's only about the amount of work that can be done, not where or how. Let's quickly revise what we've learned about energy. Energy is the capacity to do work. It's what makes motion, action, and change possible. Every time work is done, some energy is transferred from one object, form, or system to another. Energy is a scalar quantity measured in joules, and it exists in many forms, like mechanical, thermal, chemical, electrical, and light. Whether you're lifting a bag, lighting a bulb, or digesting food, energy is behind it all. I hope you now see energy not as an abstract word, but as a living, working part of everything around us. See you in the next lesson with another amazing concept of physics.